Hello everyone, and thanks for tuning in to SenGen's technical webinar series. My name is Brett Miller and I'm one of the marketing specialists here at SenGen. The topic of discussion today is SenGen's OPNFV Pharos Lab. For those who don't know, OPNFV is the Open Platform for Network Function Virtualization. In 2015, SenGen joined OPNFV as the first associate member. The partnership has resulted in some very unique and innovative network function virtualization projects for SenGen, such as StorePerf, Joid, and of course our Pharos Lab, which we will be discussing today. On June 22, 2016, while at the OPNFV Summit in Berlin, Germany, SenGen officially announced the launch of Canada's first OPNFV Pharos Lab. The launch took place at our headquarters in Ottawa, Canada. Today's webinar will be a 20 to 30 minute presentation of SenGen's Pharos Lab, followed by a panel discussion. On today's panel, we have our presenter, Daniel Tuderis, networking intern, Dave Urschatz, senior technical lead, and Michael Weir, VP of technology, as well as myself, Brett Miller, marketing specialist. If anybody has any questions throughout the webinar, please feel free to type to us using the Q&A feature via WebEx, and we'll have our panelist, Michael Weir, responding to everyone. Today's webinar will also be recorded and we will have it posted on both our website and our YouTube channel so you can watch it later. I'd now like to introduce our presenter today, Mr. Daniel Tuderis, who has been working on SenGen's Pharos Lab over the past year. Daniel is an electronic engineer with a major in telecommunications. He's currently enrolled at Carleton University here in Ottawa, Canada, completing his Master's of Engineering in Electrical and Computer Engineering. His areas of interest lie in optical networks, SDN, and cloud technologies. As part of his program, Daniel received an internship with SenGen where he was presented the opportunity to participate as an OPNFV intern to deploy the Pharos Lab at SenGen. We will now begin the webinar. Take it away, Daniel.
All right, thank you, Brett, and welcome, everyone. So I'd just like to start with a little bit of the outline that what we're going to be talking today. I'll start with a brief OPNFV definition overview over some of the projects that OPNFV covers. And then I'll move to the OPNFV Pharos Community Lab project. And then I'll be talking about SenGen as an associate member of OPNFV. And for the technical part, I'll be talking about the deploying of the Pharos Community Lab at SenGen, and what we did to test that environment, and the Jenkins connection and future work. Finally, we'll have a panel of discussion. So I would like to start with a brief OPNFV definition, actually taken directly from the OPNFV. OPNFV is a carrier-grade integrated open-source platform created to accelerate the introduction of new NFV products and services. As an open-source project, OPNFV works closely with standard bodies, open-source community, and commercial suppliers to deliver a standard open-source platform to deploy that and test NFVs. OPNFV is completely open to anyone to participate. So whether you are an employee working for a member company or just someone interested in learning and giving back to the open-source community, you're welcome to participate. OPNFV project coverage is very wide. With more than 40 projects spanning through the whole NFVI and BIM ecosystem, OPNFV currently have projects in areas of deployment and integration, infrastructure and testing environment, feature enhancement, and testing projects. In the image, we can see some of the key projects under the OPNFV umbrella. SenGen's logo has been included on the projects we are currently involved: Joid, StorePerf, and Pharos. We're also aiming to keep expanding and participating in new projects. On the left panel, we can read some of the OPNFV main achievements, as currently more than 55 companies has joined as members. Among all the projects, the OPNFV community has grew up to more than 200 developers, more than 40 approved projects, including 5 testing projects, and more than 12 active Pharos Lab provided by members, including SenGen. As we can see, OPNFV is still young, and with a lot of upcoming projects and goal to keep expanding. Its second release, Brahmaputra, came out on March, and is currently available to anyone who wants to download it and test it. For OPNFV, one of the key to its major success is the fact that they work closely with major standard bodies, like the European Telecommunications Standard Institute, or ETSI. ETSI is a non-for-profit organization, and their industry specification group for NFV has grown to over 290 individual companies, including 38 of the world's major service providers. For OPNFV to work tied together with such institute means to be aligned with a huge industry workforce. This collaboration between OPNFV and standard bodies also allowed for OPNFV participants to help identify practical experience implementing standards and provide feedback in these standard bodies. In the image on the left, we can see the ETSI NFV architectural reference. On the right, the OPNFV coverage for the Brahmaputra release, directly mapped to the ETSI reference. On the bottom of the two images, we have the NFV infrastructure where the VNF are deployed. In the middle, we can see some of the OPNFV upstream collaboration projects, including OpenStack. So let's talk a little bit about the Pharos Community Lab project. Pharos is a testbed project that holds all the rest of the OPNFV projects. Pharos became a critical component for OPNFV since it represents the physical infrastructure that hosts the deployments, testing, and continuous integration of the OPNFV platform. Currently, OPNFV has more than 12 community labs spanning through North America, Europe, and Asia. That includes our own Shenzhen Pharos Lab in Canada, which I'll be talking about in a bit. Pharos' main goal is to facilitate testing across multiple scenarios complying with the OPNFV specification. We can see on the diagram in the left a generic example of a Pharos lab composed with a jump server. The jump server has access to the NFV infrastructure to the deployer. It's here in the jump server where we run the selected OPNFV installer to deploy our environment. Below we can see the bare metals to be used to build the environment, including redundant controllers and the compute nodes for virtual machine instantiation. This diagram represents just an example of a Pharos lab, as OPNFV can support different scenarios. For example, in this diagram we are using 3 controller nodes for high availability, or HA as it's also called. But a single controller deployment, or no HA, is also possible. Even other physical variation depending on your interfaces or network resource available on the nodes. Finally, on top, we see some basic components like remote access connectivity for external users to access each lab, and also connection to the OPNFV Jenkins slave, which is used mainly for continuous integration tasks. I'll be talking about later. Pharos Lab will provide the resources required for testing and deployment of the whole OPNFV ecosystem. Following the OPNFV specification will ensure a physical abstraction and compatibility across architectures, environment, and even vendors, as currently the Pharos Lab are based on a broad range of hardware and vendors. Okay, so moving to the Shenzhen as an associate member of OPNFV. Here are the current OPNFV members. As I said before, currently more than 55 companies has joined the OPNFV. We can see here some big companies that support and participate on the OPNFV projects. Similar to OPNFV, Shenzhen is a not-for-profit organization looking to accelerate the introduction of next-generation solutions, including NFV and SDN. It became clear for Shenzhen that OPNFV goals were aligned with Shenzhen's goal. That's why in 2015, Shenzhen became the first associate member of OPNFV, and since, we have been very active with the OPNFV community. Okay, as I mentioned before, some of the projects that we are currently involved with OPNFV include JOITS, Storperf, and the reason for this webinar, the Pharos Lab project. An interesting fact of this collaboration with OpenFV is that this year, during the OpenFV Summit in Berlin, OpenFV introduced an internship program, and Sengen took fully advantage of this opportunity to have students working on these projects. We can see here on the right a screenshot of the OpenFV intern project page with Joyce Storper from Pharos project listed. The tweet in the middle below shows a picture of the first 4 intern participants in this program, including Sarah, Tim, and myself, which is pretty cool. So, moving to the Sengen Pharos Community Lab project. As I was explaining, as part of my internship project, I had the task to deploy the first fully functional OpenFV Pharos Lab at Sengen location in Ottawa, Canada. What a piece of cake, right? Of course, I built it alongside Sengen's engineering team, which helped me ensure a fully secure and contained environment. Our Pharos Lab currently consists of a single pod with possibility of aggregating more pods in the future. The current pod was built thanks to Sengen's partnership with Contron. Contron is a carrier-class cloud infrastructure provider, and our SynCloud infrastructure platform became critical for Sengen to deploy the Pharos Lab. Contron SynCloud is a fully scalable SDN and FB-enabled cloud infrastructure platform. It combines compute, storage, and networking resources in just a 2-rack units modular chassis. The chassis can hold 9 blades, also provide 5 modular fan units, 2 redundant power supplies, and 2 redundant layer 2 and 3 switch models. The integrated switch card brings all the required networking functions. The SynCloud solution was a perfect match for Sengen to deploy the Pharos Lab. It offers a 1 and 10 gigabytes internal interface between the nodes, and 10 and 40 gigabytes connection to external networks. Currently, our lab uses 6 blades, all with 16-core CMD processors and 32 gigabytes of RAM. So, we can see here in the picture on the left how the Sengen solution is just a perfect match for our Pharos Lab. All the components are integrated on a single 2-rack unit box. Part of our job was to design a secure way to allow the external users to access the lab. In the picture on the right, we have the outcome of that solution. We implemented a remote access server where users can securely connect using SSH protocol. These remote access servers This remote access server is built with isolated containers that once you access it, it will give the user full access to the project space. In this case, it's a Pharos Lab environment. Moving back to the Pharos Lab, here's the main components. The jump server on the left. This is where we deploy the selected OpenFV scenario. Currently, OpenFV offers 4 installer projects that leverage different vendor solutions like Mirantis Fuel, Red Hat's RDO, and Canonical Juju. So it is here in the jump server where we execute the environment deployment, and it is on the nodes below where we actually deploy the environment. Our Pharos Lab uses 3 controllers nodes for high availability purposes, also 2 compute nodes to deploy the VMs. It is worth mentioning that we select Joy project as our base installer. Joy relies on Canonical, Mass, and Juju solutions to deploy OpenStack. Let's take a closer look to our jump server running Joy. On the top left picture, we have the logical diagram of our jump server running Joy. We're using Ubuntu 14.04 as a host operating system. 2 kernel-based virtual machines, or KVMs, running on top of it. And the top KVM is running the mass controller node. The other one is a KVM running the Juju Bootstrap node. And don't panic, I'll be talking about this VM just next. As you can see, the two VMs are connected to Linux virtual bridges, and those bridges are mapped to the Blade's physical interface, connected to the controllers and compute nodes selected to deploy the environment. Okay, so back to MAS. MAS is an automation tool that allows you to control physical and virtual resources. Using MAS, you can add nodes, install an operating system, delete, configure IP interfaces, and other tasks all through this GUI interface. The picture on the right, we see our MAS dashboard displaying our controllers, compute nodes, and the Juju Bootstrap virtual machine. From this GUI, we can take control of all these nodes and do changes on multiple nodes just running a single command. The Juju Bootstrap node is used by Juju to deploy services using the physical resource managed by MAS. Let's take a look at that. So, at first sight, these two pictures can be really scary. It is actually quite simple. Juju is an open source modeling tool created by Canonical. It allows you to configure, manage, maintain, deploy, and scale cloud services. Juju use what they define as charms to deploy its services. Charms are just a set of scripts that are used to deploy a service, and a bundle is a set of charms working together to deploy services that requires multiple dependencies, as in OpenStack. As you might know, OpenStack is a cloud operating system that controls multiple compute, storage, and networking resources. So, in Juju terminology, if you want to deploy OpenStack, you must deploy a bundle which is made of multiple charms. In the picture on the right, we can see a Juju OpenStack bundle, and each circle represents a charm. In this case, these charms are OpenStack services like Horizon, Glance, Nova, Keystone, Neutron, etc. The lines connecting them represent the relationship between each OpenStack component. The picture on the left is just the same bundle seen from the command line terminal. Each line represents a charm or service running. Let's take a closer look. This example showed 3 running services, the Nova Cloud Controller. The reason why we have the same service 3 times is because we enable high availability. So each service is replicated among our three controller nodes. We can see here that Juju create LXC containers on each controller. The containers are in a ready state. And also, it's accessible through this IP address. The beauty of OpenFV is that everything I just showed, everything that I just showed you regarding deployment environment, it's all automated. You just need to have access to a Pharos Lab, download the OpenFV code to your Jump server, follow the instruction to run the script to deploy your environment, run the scripts, and sit back. The outcome is a fully functional OpenStack environment. So these are some screenshots I took from the OpenFV Horizon dashboard on Sengen's Pharos Lab. It is running OpenStack Liberty. Now, probably some of you might be wondering, well, how do you know this is really a fully functional OpenStack environment? And this is where OpenFV comes to action with their testing-related projects. OpenFV offers several test suites to validate the performance and functionality of your environment. The OpenFV relationship with all these standard bodies help with the creation and adoption of highly accepted test suites. In the slide, I'm just covering 2 critical OpenFV test projects, FunkTest and Yardstick. The tests, they test the Virtualized Infrastructure Manager, or VIM, and the NFV infrastructure. These tests check for basic functionalities and also look to verify the benchmark to verify and benchmark the environment's performance. Although OPNFV offers other testing-related projects for other NFV components, we started with these two, and we're planning to implement some others in the future. Okay, so while we reach to the end of this technical webinar, I wanted to mention another critical component for OPNFV and the Pharos Lab project. It is the Pharos Lab connection to the OPNFV Jenkins. For those who are not familiar with Jenkins, Jenkins is an automation tool that allows you to build, deploy, and automate tasks in your environment. OPNFV uses Jenkins mainly for continuous integration and testing. So it is through Jenkins that OPNFV set automated jobs to build the test their different projects. Some of the Pharos Lab are not only dedicated for development, but also they are continuously deploying the projects and running tests on the environments. The test results are pushed to a database for interpretation. OPNFV uses open source tools like Grafana to display test results collected from different Pharos Labs. The image in the left is showing the OPNFV Jenkins dashboard, with all the Pharos Lab connected to Jenkins and running different tasks. As you can see on the image, we recently connected our Pharos Lab to the OPNFV Jenkins. We're planning our next step to make the most out of this automation tool. Alright, so to summarize what we covered on this technical webinar, we started defining the OPNFV and the project coverage. We talked about their current release round ultra, including the Pharos Community Lab project and their specification. We then talked about the SenGen as a first associate member of the OPNFV and the project we're currently involved, like Joy, Storperf, and Pharos. I show you the SenGen Pharos Lab design and architecture and how we deploy the environment using Joy. And we test our environment using FunkTest and Joystick projects. Finally, I talk about the connection with the OPNFV Jenkins and how we are planning to implement automated tasks in the future. I really hope you had a good time listening for this technical webinar, and I would like to thank you for joining.
Thanks, Daniel, for that fantastic presentation. We can now begin our breakout discussion session. So on the panel today, we have Michael Weir, VP of Technology here at SenGen, Dave Urschatz, as well as our presenter today, Daniel Tuderis. So we'll go ahead and get started with the discussion session. We have a few questions here. So the first one will be directed at Daniel. So talk about your experience as an OPNFV intern at SenGen.
Well, so as part of my master program, I got this internship opportunity with SenGen. And then inside this internship, I got the internship project with OPNFV, so which it's pretty cool. I got to get involved with OPNFV. I didn't hear about them before, and I actually like a lot what they're doing. It's pretty cool. A lot of projects right now are moving to open source. And it's great to be part of this community. So far, the experience has been really good, excellent.
Okay, and to follow up on that, what aspects of OPNFV were involved in the creation of SenGen's Pharos Lab?
Well, the OPNFV project, they have a lot of tools that allow you to reach them, to engage with the OPNFV community and their projects. I think one of the most important tools that they're using is Git. That's where they keep all their code, and you can just join Git and clone their code and test it. They use also pretty cool tools like Jira and Confluence for their documentation, and some of the ways to reach to the community, they are using IRC channels, they're using forums, mailing lists, and even meetings. They have each project has weekly meetings, and you can attend those meetings even if you don't have anything to say, you can go there and be part of the meeting, listen to them, and start getting involved. It's pretty cool.
Yeah, I'd just like to add a little bit to that. The OPNFV, the business and development tool set that Daniel just described itself, as well as the workflow that that covers the development, the peer review, the testing, and the commit. Everything that Daniel experienced, it's a fantastic introduction to what interns and even SenGen staff will experience as they progress through their careers. And I think in the spirit of SenGen, one of its mandates is creating jobs in Canada. This is just a fantastic introduction to that environment that will help people.
Thanks, Dave. On to the next question. Was it difficult to get involved with the OPNFV community?
Well, they actually have all these tools and ways to reach them. Like I said, they have IRC channels. They are always there. When I started here with the OPNFV project, it can be pretty scary if you don't know. Like you can get really scared about how to engage to the community, or even if you don't have anything to say, like, oh, should I do this question? Should I talk with this guy? So I found out that OPNFV, their people are pretty smart. They're pretty ready to help the community. They really give back. I remember that even at some point I started to read and went to their forum. I found questions that at some point I was able to respond, and I started to give back to the community. So other people were coming in with questions, and I was able to answer. It's just a matter of getting engaged and involved, and in no time you'll be giving back, not only receiving or reading and going through the documentation.
And just a few more questions here. Which node performs the task of the neutron networking node in the Pharos Lab? This was referenced throughout Daniel's presentation, but maybe Michael, Dave, or Daniel can expand on this a little more.
Okay, maybe Daniel can take us to the Juju output, the Juju status output. So the quick answer to this is if you want to locate where it's deployed. Unfortunately, we can't see the exact detail in this slide here. If you look in the Juju status, which gives you this, you can see the nodes. In the middle column there, you'll see 1/LXC/9. Now, in this case, it's for the Nova Cloud Controller. That means that it's been deployed on machine number 1 in LXC container number 9, and you can access the ports for this service at the ports that are specified, as well as the IP address. You'll find exactly the same thing for Neutron. It turns out the Neutron gateway is typically deployed with these Juju bundles. It'll be on one of the controller nodes, but to specifically locate it, go in and log in and do some debugging. It'll be the gateway controller, Neutron gateway service that you'll be looking for. If we can go to the video slide, or the link slides, if you I guess the second link up from the bottom, Joy deployed NFVI OpenStack. There's a YouTube video there that shows you exactly how to do this process, and it's quite detailed in how to go about figuring this out. Joy is fantastic for giving you pointers to all of the services and allowing you to get in there and do debugging and testing. I hope that answers the question.
And next question, how can any company or organization get involved with the SenGen Pharos Lab? I
would think just go to the www.opnfe.org, and they have all the instructions there as to how to go about doing that. It's exactly what SenGen did. You don't have to be a member. You can just start getting involved and contributing from within a project, or your company can select how involved they want to be.
Okay, that's excellent. That's great. Thanks to both Daniel, Dave, and Michael for their discussion, and also to everybody for tuning in today for our Pharos Lab. Just a reminder that we will be sending out a follow-up email that will include all of these links and all the resources that you can use to go into a little bit further detail. Just referencing what's on the slide now, if you want to read about our Pharos Lab, you can sengen.ca/Pharos-lab, or our webinar series, Contron Sim Cloud, and then the YouTube videos. So once again, thanks for tuning in to our Pharos Lab webinar, part of our technical webinar series. We hope you learned a lot and that you'll attend our future webinars. We should have one coming up in September. This is Brett Miller, Daniel Tuderas, Dave Urschatz, and Michael Weir from SenGen, the Center of Excellence in Next Generation Networks. And that's all for today. Thanks for tuning in.